The second type of correlation we will discuss is the inverse or negative correlation. Basically, as the independent or x variable increases, the dependent or y variable decreases, and vice versa. And again, I'll be using a table to more clearly show this. First, we have the constant inverse or negative correlation. As x changes, y changes inversely the same amount or the same proportion. The most simple example of this is a one-to-one relationship. If x changes by 1, y will change by 1, but negative. So y will be negative. If x changes by 2, then y will change by 2, but negative. 3, negative 3. How do we show this? The trick is we have to start at a positive value of y when x is 0. Why is this? Because when x is 1, y is negative 1. We're here. X is 2, y is negative 2. We'll have a graph that looks like that. And we want to keep this in the first quadrant. So what we do, as suggested, going to add a constant amount to the y variable and start at a higher level. And so if we start at a higher value, what's the graph going to look like? Something like that. This shows that y is decreasing at a constant rate given an increase in x. How do we see this on the curve? As x increases by 1, y decreases by 1. As x increases another 1, y decreases by another 1. And as x increases by the last unit, y decreases by a similar amount. And so because these are equivalent amounts, the curve is straight and it slopes downwards. Our second case is the increasing inverse or negative correlation. In this situation, as x changes, y changes inversely, but at a greater proportion. Previously, we had a one-to-one constant inverse correlation. Now, as this correlation is increasing in size, and it's negative, this factor will have to increase as x gets larger. So we can have negative 2 times and negative 3 times. How is this going to affect y? When x changes by 1, y changes by negative 1. X changes by 2, y changes by negative 4. And when x changes by 3, y will change by negative 9. Graph these, and remember that you need to start at a positive value of y. An easy way to graph this is to first create a circle and then cut off everything except the upper right-hand portion and fit this to the axes. Y is decreasing. That's because at all points the curve is sloping downwards. and it's decreasing at an increasing rate. How do we see this? First, mark off 3 equal sections of x. And then draw triangles to show how much y increases every time x increases the same amount. First, x increases by 1, and we can make believe that y is decreasing by 1. It's not perfect on this graph, but you'll get the idea. Next, x increases by 1 again, but this time y increases a greater amount. Last, x increases the same amount, but this time y decreases a much greater amount. Or another way to show this, if we draw a tangent at each coordinate, the lines become steeper. What this means is that the dependent variable, or the y variable, is decreasing faster than the independent, or x variable, is increasing. Our last correlation is the decreasing inverse, or negative correlation. Here, as y changes, x changes inversely, but at a lower rate. How do we show this in tabular form? Well, if we start out at a 1-to-1 proportional change, x changes by 1, therefore y changes by -1. Now fill in the rest and show that the proportional change is decreasing. Okay, if the proportional change is decreasing, that means we go from a -1 to a negative, let's say, 1/2. So when x changes by 2, y changes by 1. And next, we can go to a smaller number, say a -1/3. A -1/3 is smaller than 1/2, is smaller than 1. So when x changes by 3, y changes by 1. So y is changing the same amount, but x is changing greater amounts. Try graphing this. And so how can you think of y decreasing at a decreasing rate? Here's a different way to graph the relation. As x increases by 1, y decreases by 1. As x increases by 2, y decreases by 1. So these two portions are the same, and this is 1 unit, this is 2 units. Next, as x increases by 3, y decreases by 1. To draw this, let's start here and go through the right angles. We start to see a downward sloping line because y is decreasing, but it's getting flatter. Whereas with the increasing inverse correlation, the line is sloping downwards, but it's getting steeper. The most common way to show this is to draw a circle and cut off all but the lower left. Before we cut off all but the upper right for increasing inverse, now we have only the lower left of the circle, and this is the basic shape of a decreasing inverse correlation. it shows that as x increases, y decreases, but at a slower rate. So in all of these circumstances, the curve slopes downwards, or from upper left to lower right. The curve is straight when there is a constant inverse correlation. It is bowed outwards when there is an increasing inverse correlation. And it is bowed inwards when there is a decreasing inverse correlation.